Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in this video we are going to study about the features of 8087 math coprocessor. The 8087 is the first coprocessor which was developed by Intel. First we will study that what is a coprocessor, why it is useful to use a coprocessor, and then we will study some features of 8087 coprocessor. So let us start with our topic. So let us first understand that what is a coprocessor. So by the word coprocessor, it means co and processor. So processor is a device which process something. Okay. So here the coprocessor, it is also a type of processor, but it is not the main processor but a secondary processor. Okay. So coprocessor is a specially designed circuit on microprocessor chip which can perform the same task very quickly which the microprocessor perform. So just like the microprocessor, the coprocessor also processes something or process the task, but its speed of doing that task is very fast. Okay, so the difference between coprocessor and microprocessor is that coprocessor does the same task which the microprocessor does, but its speed of doing those tasks is very fast. So here the word quickly is very important, that coprocessor, it performs the same task quickly which the microprocessor perform. So what is how this coprocessor is helpful for the microprocessor? Because if the tasks which are performed by the microprocessor, like the calculations, the arithmetic and logical calculations, if all the numeric tasks are performed by the coprocessor, then the workload on the microprocessor reduces and the microprocessor can engage itself in doing some other tasks which are more important. Okay, so all the calculations and numeric data work will be given to the coprocessor and the workload of the microprocessor will be reduced. So the main advantage of using the coprocessor is that workload of the main processor, it reduces. Now as I have said that coprocessor, it is a specially designed circuit on the microprocessor chip. So on the microprocessor chip itself, the coprocessor is present. So coprocessor is going to share the same memory, the same bus, the input output ports, all the devices or the components of the microprocessor will be shared by the coprocessor also. So all the main components of the microprocessor, they will be shared by the coprocessor also. Now what type of data will be handled or task will be handled by the coprocessor? Coprocessor will do all the arithmetic and logical operations, okay? Then graphical displays on the screen, they will be handled by the coprocessor, so that the microprocessor is not get busy in doing those tasks. So this is what a coprocessor is. Now the first coprocessor which was developed by Intel was 8087 math coprocessor. Okay, so first coprocessor was 8087. Now coprocessor is used along with the main processor. So 8087, it was developed to work with the 8086 family and 8088 family of the microprocessors. Why there was a need for the development of this 8087? Because 8086 and 8088 family microprocessors, they were not able to perform the high speed calculations and those mathematical calculations which were involving very large numbers or very short numbers. Okay, so for doing the calculations on these numbers and to do fast calculations and give fast results, then 8087 math coprocessor was developed, so that all the floating point calculations and calculations involving these numbers are done by the 8087. So 8087 was developed as a coprocessor for the 8086 and 8088 family of microprocessor. Every microprocessor of these families, 8086 and 8088 microprocessor, each microprocessor is having its own coprocessor. So 8087, it is the first coprocessor which was developed to pair with the 8086 and 8088 microprocessor. It is a high performance numeric coprocessor and it performs all the high speed calculations which the 8086 and 8088 microprocessor cannot perform. So this coprocessor, it performs all the arithmetic and logical operations, all the calculations which are involving the floating point numbers, because floating point numbers calculation cannot be done by the 8086 and 8088 microprocessor. Now calculations, it can be addition, it can be subtraction, multiplication, division. So all these arithmetic operations with the floating point numbers are performed by the 8087. Now as these tasks are performed by the coprocessor, so microprocessor is free from these tasks, so the CPU involvement or the CPU storage is being reduced. Okay, because CPU is free from these tasks, the CPU of the microprocessor is free from these tasks, they are now performed by the coprocessor. So the microprocessor, it can involve itself for doing some other tasks which are more important and involve the functioning of the microprocessor. Now let's see some of the features of this 8087 math coprocessor. So as I have said that it is the first coprocessor which was developed by Intel to pair with the 8086 and 8088 microprocessors. Now this coprocessor, it introduces 16 new instructions to the instruction set of the microprocessor, and this instruction set is available to the programmer so that the programmer can perform the operations on the floating point numbers also. So along with the instruction set of the microprocessor, it is having 60 new instructions. So coprocessor, we can say that it has its own instruction set, okay, and it is optimized in such a way that it can perform the calculations on floating. High speed calculations can also be performed by it. So 60 new instructions are added to the instruction set of the microprocessor, and these instructions, the mnemonics of all these instructions, they start with the alphabet F, which indicates that it is the instruction for the floating point numbers, okay. So the difference between the instructions of 8086 microprocessor and the coprocessor is that coprocessor instructions will have the mnemonics starting with the alphabet F. For example, in the 8086 microprocessor, for addition and multiplication, we were having the instruction ADD and MUL. ADD is for the addition and MUL is for multiplication. Now it will be changed in the coprocessor. F will be added, FADD. Okay, and for multiplication it will be FMUL. So the difference between the instructions of the microprocessor and coprocessor is that coprocessor instruction will have the alphabet F in their as a prefix, whereas in the 8086 we will not have the F alphabet. Okay. Now, there are some other names also for this 8087 math coprocessor, like it is also called a numeric processor extension. So the other names for this coprocessor are the numeric processor extension, that is NPX, then numeric data processor NDP, and floating point unit FPU, depending upon the functions which it performs, because we know that it deals with the numeric data only. So numeric data, and it's a processor because it is processing that data, doing calculations over it, and also it is dealing with the floating point number, so it is sometimes called the floating point unit also. So these are the some other names of this math coprocessor. So as this coprocessor deals with the numeric data, so this data can have different data types, like it can be a decimal number, it can be a floating point number, okay, it can be integer, it can be a real number, okay. So there are different data types on which this 8087 coprocessor deals with. Also, as I have said, that it do all the types of arithmetic and logical calculations. So 8087 is capable of doing all the type of complex arithmetic and trigonometric and logarithmic calculations. So if there is a different variety of calculations can also be performed, and all the type of high speed calculations which are involving either large numbers or very small numbers can be done by the 8087. So it is capable of doing complex arithmetic and trigonometric calculations. Because we know that the microprocessors, the 8086 and 8088, there are some calculations or there are some programs in which we have to find the sine of any angle, or trigonometric identities we have to calculate, or any logarithmic angle we have to calculate, and we have to deal with the large numbers also. So for that, the 8086 microprocessor and 8088 microprocessor, they are not capable of calculating them. So for that we need the coprocessor, and which is the 8087. Now, as I have said that this 8087, it is the processor in itself also, okay, means that it is having its own architecture, it is having its own instruction set, and it is dealing and working in the same way as a microprocessor does. Okay, just the difference is that it is not the main processor, but it is a secondary processor which is working under the host processor. Okay. Now, as this 8087 is working with 8086, so in the 8086 microprocessor, we know that it first fetches the instructions. 6 instructions are fetched at a time. Then these instructions are kept in a queue. After that, the microprocessor, it starts decoding the instructions and execute them. Okay, just like the same way 8087 also just fetches the instructions, then decode those instructions and execute them. Okay, so whenever any instruction is fetched, the instruction is kept in the instruction queue of the 8086 also and of the 8087 also. Suppose that here we have any instruction written in the program. Now this instruction will be fetched by the 8086 also and by the coprocessor 8087 also. Both these processors are going to keep this instruction in their instruction queue. When 8087, it decodes that instruction and finds that it is not the instruction of its instruction set, because as I have told earlier that the difference between the instructions of 8086 and 87 is that in 87 we are having the F prefix, whereas in 86 we are not having that prefix. So it will just check that, suppose FADD, it will check that F prefix is there. So 8087 is going to execute that instruction. If it finds that the instruction is ADD, then 8087 will treat that instruction as an NOP instruction. That is, no operation will be performed. And that instruction will be executed by 8086. Suppose that FADD is encountered by the 8086, then 8086 identified that it is having prefix F, so it will treat that instruction as NOP. So instructions of 8087 will be treated as NOP instructions by 8086, and instructions of 8086 will be treated as NOP instructions by the 8087. So in this way, they differentiate between the instructions and execute those instructions. This is how the processor works in association with the coprocessor. Okay. Now all the instructions of the 8087 microprocessor coprocessor, they come with a code. So all the 8087 instructions, they have the code 11011. How this code is given? This is the first byte of the instruction. By using the prefix escape to that ESC to that instruction. So by giving that prefix, it will have the code 11011, which helps the microprocessor to identify that it is the 8087 instruction. It is not of 8086. So in this way, the processor and the coprocessor, they work in association with each other. So here we studied some features of the first math coprocessor 8087. We saw that its speed of calculating the complex calculations, doing the complex calculation is 100 times faster than the 8086 microprocessor, and because of it, that feature that it is doing high speed calculations, it is used along with the microprocessors. We studied some features. We studied that what is a coprocessor, why it is developed, and how it is useful for the microprocessors. So I hope that this topic is now clear to you. Thank you.